So today's lesson is actually going to be very similar to what we did on Thursday, which is good for you because it shouldn't be too much of a big step into today's math lesson, okay? But today we're using rectangular fraction models. So far, is that the same? To add fractions. So far, is that the same? Except today's sums are always going to be between 1 and 2. What does that tell you about the answer that you get? It's probably going to be a what kind of fraction? Improper fraction. Have we learned how to separate out the whole from the improper fraction?
Yeah.
So that's basically all you're going to have to do today. After you add, you're going to have to use rectangular fraction models to make the denominator the same. What's another way to say denominators that are the same? Like denominators. And then, after you're done adding all the fractional parts, you're going to have to say, is this an improper fraction? If so, let's make it into a whole number plus a fraction. Make sense? Great. So the directions say, for the following problems, you're going to draw a picture using the rectangular fraction model. What's another word for rectangular fraction model again? Good. And we are going to write the answer. When possible, we're going to write our answer as a mixed number. What is a mixed number? Well, a mixed number is called a mixed number because it's mixed up. It's like a mixture. What's a mixture? It's anytime you combine two or more different things. So a mixed number, to relate it to science, it's a mixture because it has two or more different things. It actually has two different things. It has a whole number part and it has a fraction part. So an example of a mixed number might be 1 and a half. It has a whole number part and a fraction part. Another example of a mixed number might be 26 and 2/3 because it has a whole number part and a fraction part. Does that make sense? Okay. Whenever we have an improper fraction, we can write it as a whole number and a fraction, which is why it's called a mixed number. Okay? But moving on to the problem, we have 3/4 plus 2/3. Go ahead and write that problem into your notebook. Are we ready to add them up? No, because the denominators are different. They have unlike denominators. Okay? So let's draw them into rectangular fractions models so that we can find equivalent fractions. If this is 1 and this is 1 and I want to make 3/4, I have to split it into 4 equal-sized pieces and I have to color in 3 of them. Do you agree? Yes? Okay. Remember that we always draw the first one vertically and the second one is always what? Horizontally. I'm also going to label that this is 3/4. Now over here I have to make 3 equal-sized portions because it says 2/3, so I have to split it into thirds. And then I have to color in 2 of them because 2 of the thirds are what we're working with here. Okay, I'm going to, of course, also label that 2/3. Now, if I want to split it up, if I want to overlap those, I have to cut my fourths now into thirds as well, yes? And I have to cut my thirds into fourths vertically. And now I can write my my equivalent fractions. How many equal-sized pieces are there now in one unit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, what? 12. So that means my new denominator is 12. Now, for the 3/4 side, how many are colored in? How many boxes are shaded in? 8? Go ahead and count them carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see here if you are not careful with your work and very precise in your drawing and your shading, could you get answers wrong? Okay. What about over here on the 2/3? Now this one unit is also divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units altogether. So that means that's my other denominator. Okay. And how many are colored in? 1, 2, 3, 4, 5, 6, 7, 8. So if I wanted to rewrite this problem 3/4 times 2/3, or plus 2/3 I should say, I can use my new equivalent fractions to rewrite it as what? 9/12 plus 8/12. If I have 9/12 and then I add 8 more, how many do I have altogether? 17/12. I know that this is an improper fraction because the numerator, 17, is bigger than the denominator, 12, right? That means I have at least one hole in there. How many 12s does it take to make a hole? 12. That means I can split this 17/12 into 2 parts. Is there a part that's 12/12? And after I separate out 12 twelfths, how many twelfths are left? 5 twelfths. So that means that this 12 twelfths part is equal to 1. I'm going to write it over here. And then what's the fraction part we have left? 5 twelfths. So my final answer is 1 and 5 twelfths. And this is how you write a mixed number. You just write the whole number part and the fraction part right next to it. Now, how can we show this mixed number with our picture? Well, imagine I'm going to color in all the parts we have, okay? Here's 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths. Do you agree? Yeah. Now, imagine I had some scissors. I'm just going to cut out this 12th and move it over here. I'm going to cut out this 12th and move it here. I'm going to cut out this 12th and move it here. Now is my entire, sorry, give me 1 second. Okay, now is this entire hole taken up with the green 12ths? That's one hole, isn't it? Now, how many 12ths do I have left over here? I have these over here, right? And how many 12ths is that? 5 12ths. So can you see that this part right here, this is your hole. This is the one.